Alright, so here are the answers to the problems on the back, and the first two we completed using the inscribed angle theorem, which says that the measure of the angle is equal to 1/2 the measure of the arc. Right? So they give us the measure of the angle, so it's angle is equal to 1/2 the arc. They give us the angle, so we'll plug that in. We're multiplying both sides by 2, so we get that measure of the arc is equal to 2 times the measure of the angle. And then we plug in the measure of the angle and get 72 as the measure of the arc. So over here, are we doing the same thing? Yes, we're doing the same thing. So we have the measure of the angle is equal to 1/2 the measure of the arc. We solve for the measure of the arc, and we get 266. Over here on A, this one might be a little bit tricky, but you need to understand that angle ABAC is intercepting this arc here, right? And angle BDC is also intercepting that same arc. And we know from the earlier chapters that the measure of the angle is equal to the measure of the arc. So since both of these angles, angle A and angle D, are both intercepting the same arc, that means that their angle measures are the same. So we can go ahead and set them equal to each other and solve for y, right, which we did right here. Y is equal to 10. And then if you notice on angle B and angle C, they also both intercept the same arc, which means their angle measures are the same, which means we could set their expressions equal to each other and solve for x, which we did here. So now that we have x and y, we can easily find angle A and angle C by substituting in. And over here, we're trying to find x in this expression, in this diagram. What do we have? Okay, so this one here uses the properties of inscribed polygons, which states that a quadrilateral inscribed in a circle, oh no, not that one. It's that if an inscribed angle of a triangle intercepts the diameter of the circle, then the angle formed is a right angle. And so if we're over here, you can see that angle R, inscribed angle RST, intercepts the diameter RT, which means that that angle there, RST, is 90 degrees. So if we have that's equal to 90 degrees, and we apply the triangle angle sum theorem, which says that angle measure plus that angle measure plus 90 is equal to 180, and we go ahead and solve for x. X is 16. Right? And then to find angle T, we just substitute in the x, and we're ready to go. This one here requires us to use the property of inscribed polygons, which states that a quadrilateral inscribed in the circle, the opposite angles are supplementary. So that means that these two added together equal 180, and that these two added up together equal to 180. Right? So we're able to find x and y. And then we're going to go and substitute in to get our angle measures.